Okay, this is the video for graphing piecewise functions that involve linear functions. And you need to find the cut points. Okay, and you see on 21, sometimes there's like two ends of them. So I'll do my best to explain cut points. So on 20, we have, I'll do number 20 here. 3, 4 open, and then we're going to have 3, 6 minus 4 is 2, 3, 2 open also, open circle, and then 1 going one way, so the top will be to the left because less than or equal to is left, or less than and greater than or equal to is to the right. All right, so 3, 4 open. Okay, and we're going to make this graph go to the left. So we want to apply the slope of 1. You could go down 1, left 1. That's like 2 negatives. You just have to remember that when you deal with slope, if you have a positive slope, which this is, you are going uphill left to right. So that's the way of knowing that you applied it correctly. Or, if you can't think in terms of negative, negative, -1, -1, you could go to the right, which is the wrong way, but just make the line the other way. Is another way to think about it. Okay, so if you're on the wrong side, just make the line the other way. Okay, so 3, 2 open right here. And then we want to apply a slope of 2. So up to right 1. So there's that portion of the piecewise function. So sometimes going left is a little bit harder game with applying the slope. Okay, so just go to the right and then erase that part if you need to. All right, so on 21, you see, and I don't think we're going to have one like this, but I'll just do it to do it, and then I'll do some on these other pages, one each maybe. So you notice that you have kind of 1, 2, 3 cut points here. So we have to do those. So -6, -18 minus 4, ooh, -22. This will be closed. And I might abandon this problem because of the scaling. And then 3, 9 minus 4 is 5. So 3, 5 would be open. And then here 3, 7 would be closed. And then 6, 4 would be open. So I'll try to get the part of the graph on here that I can, and to show you the idea. So -6, -22 is off the scaling here, and we could probably rescale it by 2 or 4. I'll try not to do that to show you our idea here. So 3, 5 is open right there, and that's going to end it. So -4 is our y-intercept, and we're just going to be going out to -6, but we won't even see that part of it. So it'll look like this, and then if we had an extended graph, you'd actually see the closed circle out there. So 3, 7 is right here, and then 6, 4. So 3, 4, 5, 6, 1, 2, 3, 4, and open. And so what happens now, because of these cut points, these endpoints, you just have this piece of the graph, and you just connect them. You don't even need to do the slope. The slope is -1. So however you want to do it, down 1, right 1, down 1, right 1. But you have all those cut points to deal with, and the cut points are the huge thing, figuring those out correctly and whether they're closed or open. And it's a game of, this is the X, put it in, get the Y, and then determine if it's closed or open based on that sign. All right, let's do a couple on the back here. We'll do, oh, that's my answer key there. All right, so we'll do a couple of these on the back here, and maybe we'll do problem 26 and 23, and I think that should be good enough. Again, cut points are everything, so we want to determine those first. And let me get my act together here. Okay, so 2, 3 will be closed. And that's going to be left because it's less than or equal to 2. And then 2, 1 will be open and to the right because that's greater than. So 2, 3 closed. And then we want to apply a slope of -1. Okay, so up 1, left 1, up 1, left 1. Another way is to get the y-intercept and just extend it in the right direction. So the y-intercept is 5, extend to the left. That's probably the easier way now that I'm showing this as opposed to the slope. So 2, 1 open, and then the y-intercept is -1, but we can't go in that direction, so you just take your straight edge and extend it the other way. That's probably the easier thing to do now that I'm seeing this. And go the other way from the y-intercept. Okay, so here you have 3 different values. So this is going to be -3, 2 closed. And these will be horizontal lines. -3, -1 open. And then 3, -1 open. And then 3, 3 closed. Okay, so -3, 2 closed, and -3, -1 open. All these points have to go on here. And then 3, -1 open, and then 3, 3 closed. All right, so we're 2 less than or equal to -3, so that's like this. And then between -3 and 3, we have -1. And then to the right of 3, we have 3. Now you won't get one like this, okay, on your quiz, but that is what you would do with that. And again, if you had these 3, you would do the same thing and find the cut points and then construct the graph appropriately. They just wouldn't be all horizontal lines. That middle one would be a diagonal, have a diagonal slope to it. Okay, so that is how to graph linear functions. And again, I think that probably the best way after you get the cut point is to extrapolate from the y-intercept and then just go in the correct direction. That's probably the easier thing to do with the graph instead of trying to always apply the slope. Okay, so these are the solutions for the second assignment for quiz 4 in Algebra 2C.